Welcome, brothers, to this visual operational guide. Today, we're tackling one of the most frustrating, panic-inducing issues you can ever face on shift, a jammed lime pump caused by slurry clumping. If you've run a wastewater treatment plant for any length of time, you know exactly the nightmare I'm talking about. You're just trying to keep your plant balanced, and suddenly, the dosing system decides to fight back. Have you ever been on shift when that dosing pump suddenly jams, the pipes get blazing hot, and your biological tank's pH starts dropping unstoppably? Yeah, we've all been there. The alarms are blaring, the pump is shaking like it wants to tear itself apart, and you're watching your effluent quality just crash in real time. It's high stress for sure, and it can quickly lead to compliance violations. But today, we're going to learn exactly how to beat it. Before we grab our wrenches and try to fix the machine, let's take a quick second to remember the chemistry behind all this chaos. Quicklime naturally sucks up carbon dioxide from the air to form calcium carbonate, which is basically solid rock. Plus, that hydration reaction when you mix it with water, it generates intense heat. If your saturated lime solution isn't constantly agitated, it settles right at the bottom of your tank and hardens into concrete-like lumps. Understanding that behavior is literally your first line of defense. So, here's our game plan to get from chaos to total control. We'll start with an overview of the incident, identify the phenomena, run through some diagnostic checks, dive into thorough troubleshooting, lock down how to prevent recurrence, and finally, go over our lessons learned. Section 1. Overview of the incident. When the slurry hardens. Let's look at what actually happens when a lime system chokes. When those concrete-like lumps jam up your pump, you instantly lose your continuous alkaline feed, and that triggers a brutal domino effect. Without the lime, your pH drops uncontrollably. This completely ruins your coagulation, leaving you with murky, cloudy water instead of a nice, clear supernatant. Even worse, it stops heavy metals from precipitating out, and it can literally suffocate the delicate microbes in your biological tanks. And hey, let's not forget the massive repair costs from pumps running dry or mechanically overloading. This isn't just a basic mechanical failure, brothers. It's a full-scale biological and chemical crisis. Section 2. Identifying phenomena. Spotting the blockage. Look, you don't really have to guess if there's a blockage, right? The system is practically going to scream at you. You'll know you're in trouble when the pump motor starts grinding loudly and vibrating violently. Your flow meter will just tank, dropping from, say, 100 liters per hour straight down to 0. You'll also see massive, highly dangerous pressure spikes on your gauges. And here is a crazy detail you'll notice out in the field. The pipes will actually get physically hot to the touch, especially right at the 90-degree bends or check valves, just from the extreme friction. You might even spot a rapid sludge buildup in the mixing tank and completely lose that distinct lime smell at your dosing point. Section 3. Diagnostic checks. The 7-step investigation. Once those alarms start ringing, we've got to systematically trace the root cause. First step, visually check that mixing tank. You're looking for floating hard lumps, and you need to verify your concentration is right in that sweet spot of 5 to 10% using a mud refractometer or the dry weight method. Next, grab your infrared thermometer gun and tempt that pump rotor. If it's burning up above 70 degrees Celsius, you've got a major mechanical issue on your hands. Check the motor's electrical current too. A huge spike means it's mechanically jammed with lumps, while a sudden drop usually means it's running dry. Finally, read the pressure gauges before and after the pump. If pressure shoots up after the pump while your flow drops, boom, you've isolated the choke point to the discharge pipe. This next step is where we get really hands-on. Grab a small tool and physically tap those PVC pipes. Listen closely to the sound. A dull thud, you found a solid blockage. A hollow sound means you're clear. You really want to pay special attention to those 90-degree bends and any narrow choke points. Also, take a good look at your dry lime powder. Ensure the moisture content is strictly below 5% so it isn't clumping in the bag before you even get a chance to mix it. And please, verify your dilution water isn't too cold. Water under 15 degrees Celsius absolutely kills lime solubility and slows down hydration, which practically guarantees uneven settling and a clogged system. Section 4. Thorough troubleshooting from emergency to root cause. Okay, so we know exactly where the blockage is. In those first 24 hours, your absolute priority is just survival. Step 1. Hit that emergency stop on the lime pump immediately. Seriously, do not wait. If you let it run dry or overpressurize, you're going to burn out the motor or completely blow the mechanical seals. Step 2, quickly switch over to a backup alkaline source like soda ash to keep the plant's pH in check and keep your microbes alive. And Step 3, securely isolate that blocked pipe section by closing off the valves on both ends. You absolutely have to stabilize the plant before you start wrenching on the equipment. Once things are stable over the next 1 to 3 days, you have to dig into the root cause. Day 1, completely drain that slurry tank into a collection system, never ever straight into the environment, obviously, and physically scrape the hardened tank bottom using shovels and high-pressure water. Day 2 is for the pump. Dismantle the rotor and chamber and give it a mild 5 to 10% hydrochloric acid bath for about 2 to 4 hours. That's going to dissolve that stubborn calcium carbonate. Then, on day 3, unbolt the pipes, especially those bends, and blast them out with high-pressure water. If the blockages are really severe, you might actually need to soak those pipe sections in the dilute acid too, and then aggressively scrub them out. Now, brothers, please listen incredibly carefully to this next safety warning. It is absolutely crucial. Never, ever pour concentrated acid directly onto dry lime crusts. That reaction will generate dangerous, rapidly expanding hot gases, and it can blow back on you. Always use dilute acid, make sure you're working in a highly ventilated area, and gear up properly. We're talking a face shield, chemical goggles, and heavy rubber gloves. Always, always put your personal safety way above getting the machine back online quickly. Section 5. Preventing recurrence, upgrading maintenance. Look, fixing the pump is only half the battle. Now we need to lock down some strict protocols so you never have to deal with this nightmare again. You've got to clean that slurry tank weekly and check the bottom sludge daily. Mechanically protect your pump by installing 2 to 5 millimeter mesh suction filters and throw in some Y strainers right at the lime loading point to catch any stray uncrushed pebbles. On top of that, you absolutely must enforce a strict 15 to 30-minute mechanical mixing time for every single new batch before it ever touches the pump. And hey, always keep your inventory stocked with spare diaphragms, mechanical seals, and hoses so you're never caught off guard. To really prevent this from happening again, you have to build monitoring right into your daily routine using an inspection log. 3 times every single shift, record the pump flow, pipe pressure, motor current, effluent pH, and the depth of the bottom sludge in the tank. For you to consider this incident truly resolved, these numbers must stay absolutely stable, within a 5% margin for 14 continuous days. If your pressure stays flat, the pump runs quiet, and your pH holds steady, you've officially conquered the issue. Section 6. Lessons learned. The golden rule of lime. As we wrap up this operational guide, let's lock in the single most critical takeaway from this entire procedure. Remember the ultimate rule of wastewater chemistry. Never pour water into dry lime. I'm going to say that one more time just to make sure it really sticks. Never pour water into dry lime. Always add your well-ground lime slowly to a tank that already has the required volume of water in it, and make sure you keep that mechanical mixer running the entire time. Pump blockages are usually just a cascade of tiny failures. Bad lime quality, lazy mixing, ignored maintenance schedules. If you follow this golden rule, respect the chemistry, and keep your dilution water above 15 degrees, your plant is going to run flawlessly. So, are you ready to implement these checks on your very next shift and ensure those pumps never seize up again? Stay safe out there, brothers, and let's keep those plants running clean.